Welcome to our virtual tour. Sorry we can't all be together out here, but we'll do a little bit of a tour through Blacksburg and campus to look at some best management practices. So we'll start today at Wong Park in Blacksburg and take a look. We're at Wong Park. It's one of the parks here. And now I'll show you the first thing that the town has done as a best management practice. And right here we have an example of pervious pavement for parking. They've tried to do this in a couple of places where we get infiltration instead of runoff and stormwater, at least in the parking area. One thing about BMPs, they need maintenance in many cases. Here's a case where I don't know how much longer this is going to hold up, but this is an example of one type of impervious pavement. Okay, I'll show you a couple other spots here before we move on. So we're still at Wong Park. This is a very small detention pond, also in this case called a little rain garden. But this will capture runoff from the asphalt impervious surface. These types of ponds are set up to hold water for a short time. Right here is an overflow. And this is just a small example. They've planted river birch, a hydric type plant that's well adapted to wet soils. I don't know what kind of shrubs these are, but the idea is you put in water-loving or hydric plants. And this is just a little detention basin. Here are pipes that are draining the parking lot. Comes in here, sits here, and doesn't go into the streams, hopefully. Okay. We're still at Wong Park. This behind me is a large detention pond again. This is designed to hold back floodwater that comes during major storms. It's on public property, so this is a large detention pond that the town put in as part of their TMDL efforts to protect Stroubles Creek. So this is usually dry, except during big storms. It will hold back water and slow it down for delivery down the Stroubles Creek. Okay, we're finished up at our first stop at Wong Park. So we saw some pervious paving in the parking lot, a small rain garden or a very small detention pond that helps drain the impervious pavement on the parking lot. And then we saw a very large-scale detention pond that picks up a lot of stormwater coming off the neighborhoods on the east side of town here, northeast side. So now we're going to head over to the YMCA on North Main and see an urban stream that will be quite amazing as to how they can urbanize and control water to go under buildings. That happens a lot in this town. All through the town there are streams that are underneath the structures. Okay, now we're at the YMCA. We're behind the Y and we're in a very urbanized stream. This is Webb Branch. It's one of the branches that flows into Stroubles Creek. This is very urbanized, as you can see behind me and up and down the stream. It's basically a trench in an urban setting. There's pipes, there's a sewer line that runs alongside it, there's a water line that runs through here, and encouraging, in the apartment building behind here, there's actually a little rain garden with overflow here of the stones, you can see, for the overflow of the rain garden back there. So they are making an effort to retain some stormwater, but this is an urban stream, and it's now going to run literally underneath the building that the YMCA is in. Now we're literally going under the YMCA here. We're in the same stream, part of Webb Branch. There are actually little fish in there as I'm looking down, little chubs of some sort. There is life, but this is about as urbanized as you can get, literally flowing underneath the building. Most of the streams do this in Blacksburg. Okay, so now we're on campus. We are downstream a little bit. Behind me is the new classroom building, and Webb Branch has basically flowed underneath the parking lot, underneath all of the engineering buildings. It's underground, and right here, as it crosses West Campus Drive, it comes back into daylight and empties into the upper duck pump. So that's where Webb Branch has come into the upper duck pump. It's daylighted again. And that's after it disappeared underneath the YMCA. Okay, now also here is our first example of a retention pond. Now we're retaining water as opposed to just detaining it during a storm. This is a retention pond, and the water stays here. The idea is sediment settles out, nutrients are cycled. It's basically a wetland, and the idea is water stays, overflows during major storm events, but this is really retaining water all the time and letting lots of sediment settle out, and lots of nitrogen and phosphorus hopefully get cycled into the wetland plants and biota.
Okay, what we have here is an off-stream waterer for cows, for cattle. It provides a source of water, an alternative to drinking from a nearby water source like a stream or pond. It's beneficial for the environment as well as for the cows, and possibly for the farmer's bottom line as well. When we get the cows out of the stream, there's an immediate benefit to the environment. We're no longer seeing the cows defecate into the stream, which they're not introducing bacteria and nutrients into the stream. It's being kept up here on the pasture where it can decay and be incorporated into the soil. In this case, we have a stream just down here. In this case, this is the tech pasture, so the pasture is actually fenced to keep the cows off the road and so forth. But in many cases, there would not be a fence. The stream would still be there, the cows potentially could still have access, but because of the waterer provides such clean, convenient access for the cows, they prefer actually to drink from the off-stream waterer. As I mentioned, this can prevent diseases to the cows as well. It prevents damage to their feet and so forth. And so it can be a win-win situation for the farmer and the environment. However, the waterer is expensive. You have to put in underground pipe to a well or other water source, and you have the waterer itself, so there is expense for that. In many parts of the country, I'm not sure if this waterer has a heater, but in many parts of the country you might also need to have heat to keep the waterer from freezing in the winter. So all of that is an expense, but there is cost share available through the USDA EQIP program. The farmer can get up to 75% cost share for installing the water. So this is another win-win, possibly a win-win situation for the environment and the farmer's bottom line. Okay, here we have another close-up of the waterer itself. You might have seen the cows in the background just checking us out, what we're up to. But as you can see, this waterer is not a simple affair. It does involve some expense there. There's a float mechanism in there you can see to regulate the water coming into the waterer. There's also these covers here that basically they serve to keep the water warmer in the winter, prevent freezing, and so in many cases you can get by without supplemental heat and still not have to worry about the water freezing over. We're on a concrete pad here, so there's the expense of putting that in, again trying to just prevent erosion, sediment erosion from the area around the water where the cows are congregating. And then of course you have to have a water line coming in from a well, wherever that may be. So there can be considerable expense involved. But again, just to repeat, the cost share is available, up to 75% from EQIP. And also there's other benefits, as we mentioned, to the farmer, to the herd, from having this clean source of water available, as opposed to going into a stream that may be muddy and maybe carrying some disease as well.
Now we're down at Stroubles Creek. Stroubles Creek doesn't really officially start until it drains out of the duck pond. At the waterfall at the duck pond, that is the beginning of Stroubles Creek. Above that, it's several branches. Central Branch, where we started our tour, and Webb Branch, where we went through the YMCA, underneath the YMCA. Those are the two branches that come together and meet at the duck pond. And then below the duck pond, it forms Stroubles Creek. So here we're at the bridge that goes over to Heathwood. Behind me and with me here is some efforts to restore the riparian buffer between the cow pastures and the stream. Up until about 10 or 15 years ago, the pastures went right down to the stream. Here we have a buffer planted with trees. The cows no longer get down to the stream, they're fenced off. And Stroubles Creek is on its way off of campus through the ag sites here and further down into the woods, and it heads on to the new river where it empties into the river near Radford. So there's lots of efforts here to restore things. The stream group in the Biological Systems Engineering Department has done major efforts to sample and restore some of the habitat here with plantings and restoration efforts. In front of me is typical restoration of riparian buffers. As you can see, for this type of BMP practice, it's going to take some time. We're not going to have automatic results, but it's a step forward. And this is something we talked about last week in class. There's some lag time here between some of these practices and results. So behind me here at Stroubles is a gauging station and a stream sample monitoring station powered by solar panels. The important thing we like to point out as part of this whole BMP TMDL effort is the necessity for monitoring. We can't just put these practices into place and then walk away and assume that everything's going to take care of itself. So here's an example of a monitoring station that's continuously monitoring water quality data, and you can access this data or these data on the stream website. There's live real-time data that's downloaded continuously, and during storms you can watch what happens. But monitoring is a really important part of the whole process to do best management practices. So just to finish up here at Stroubles Creek, we're talking about fairly significant efforts to restore Stroubles and improve habitat and water quality. What I want to point out here is we've talked about partnerships and stakeholders and the necessity to get people to work together. So here we've got BSE, the department, we have McCormick and Taylor engineers, we have Wetland Studies and Solutions, and we have a state agency working together here with cost share and efforts to help reestablish some riparian buffer along Stroubles Creek to improve water quality as it heads off campus here. I also want to point out the importance of student organizations as part of this too. Here we have American Water Resources Association and the American Society of Biological Engineers. I assume that's what that means. But these chapters have helped work down here, and they're part of the partnership as well. So thank you, students, for being part of this. Now we're at Hobby 1 building. This is a LEED certified building, meaning leadership in energy and environmental design. If you'll notice, there are no downspouts, no rain gutter pipes. Everything goes into this detention rain garden here that's planted with trees and shrubs that are adapted for wet conditions. And so all the runoff from the building, which normally goes out through rain gutters and downspouts onto parking lots and as stormwater, gets detained here during storms. Everything stays here within this swale around the building, so it has no net effect on any runoff. This is what we look for, and what the campus is doing in any buildings they build these days are LEED certified. So there's a couple of other features here. In front of me is overflow from the parking lot. They also use this rain garden detention pond to pull off some of the stormwater coming off the impervious pavement of the parking lot that's on the other side of the filming. The other thing they have in here are monitoring wells where they can look at the condition of the soils, look to see if there's any groundwater, and do some monitoring of the condition out here. And then over on the one side, for all of these detention ponds, they almost always have an overflow system, whereby if the water gets high enough, it will flow into that overflow and head into what I think is a sewage system. So there are mechanisms to control for overflow and localized flooding. They pull it off when it gets too high, and they connect into the sewage dispatch system. At this location, we have a new retention pond. Just wanted to stop here for a few minutes and show you what they look like when they're first established. We're next to the president's house on my right. And this, and behind me, is Wallace Hall and Linton Reeves. This is a pipe you can see coming out that drains all of the parking lots behind me, so that all that runoff comes down here, filters its way through this detention pond. We're not retaining water here, we're just detaining it for a little while during storm events. They have an area that they've designed where it's very pervious, where it'll drain through at the bottom where you see the muddy cage. And then there behind that is the cage up on the lawn, that's for overflow. But the idea here is all the runoff coming off the parking lots gets detained here during storms. And if you come over, walk through here, ride your bike through here, you'll see this fill up after we have a significant rainstorm. Again, the idea is hold it back, let the sediment settle out, some nutrients get taken up by algae and microbes, and hopefully have all this stormwater enter Stroubles in much better condition than it was before it got into the detention pond. All right. This concludes our virtual tour. I'm sorry we couldn't do this in person this year, but I hope you got a look at some of the best management practices that we have here in town and on campus in our efforts to do some watershed management that protects water quality for the long term. Take care all.